Welcome back to Talk Tensors, the show where we break down some cutting-edge machine learning research, so you don't have to.
Yeah.
Today, we're taking a deep dive into GUI-Bee, align GI action grounding to novel environments via autonomous exploration.
Catchy title.
Yeah, don't let the title intimidate you. It's all about teaching AI to navigate graphical user interfaces.
Yeah.
It's like the ones you use every day, on your phone and computer and all that.
Exactly. And it's a fascinating paper because it really tackles this core problem in AI, what we call brittleness. So imagine you've trained an AI to book flights on a specific website.
Right.
And then the website gets redesigned and all of a sudden your AI is lost. It doesn't know what to do.
Right.
So this paper is exploring how to make AI more adaptable so it doesn't, break down when it encounters a new digital landscape.
That makes a lot of sense. So how does this GUI-Bee system work? It sounds like it's some kind of super smart AI explorer, right?
Yeah, that's a great analogy. GUI-Bee acts like a digital explorer. It's charting unknown territories. Instead of being explicitly programmed for every possible scenario, it uses a multimodal large language model, or MLLM. You can think of this as a cutting-edge AI that can understand both text and images, making it perfect for understanding these graphical interfaces, understanding and interacting with them.
Okay, so it's not just looking at the GUI, but actually trying to understand it like a human would.
Precisely, yeah. And here's where it gets really interesting. GUI-Bee doesn't just blindly click around. It uses this approach called Q-value incentive in context reinforcement learning, or QICRL.
Nice.
Essentially, it learns to prioritize actions that lead to new and informative discoveries.
Oh, so it's like the AI gets curious and wants to learn more.
Exactly. So instead of getting stuck in a loop, clicking the same button over and over again, it's constantly seeking out new information about the GUI.
Gotcha.
Which ensures it learns and adapts to the unique features of each website or app it encounters.
That's super clever.
Yeah.
But how does it actually learn? Like, does it just take screenshots and try to figure things out?
It goes beyond just screenshots. So as GUI-Bee interacts with the interface, it actually generates questions about what it sees, just like, a curious human user might.
Wait, the AI asks questions. So is it like typing into a search bar or something?
Not quite. It generates two types of questions internally.
Okay.
So System 1 questions focus on appearance, like what is that button with the shopping cart icon?
Huh.
And then there's System 2 questions. These try to understand the functionality. So like, what happens if I click this drop-down menu?
So it's building up an understanding of both what things look like and how they actually function within the GUI.
Exactly, yeah.
That's impressive.
And all this data, all this exploration, the questions, the outcomes of actions are used to fine-tune existing GUI grounding models. It's like giving these models specialized training on that specific new environment that they are exploring, which makes them much more accurate.
So GUI-Bee is not just learning for itself. It's actually helping other AI systems get better at understanding and interacting with GUIs.
Exactly, yeah. It's a two-pronged approach. Exploration to gather data, and then using that data to improve other AI models for, real-world GUI automation tasks.
This has already sounded like a major development in the field, but before we dive into the results, I think it would be helpful to understand, the historical context. Where did this all begin? How did we even get to a point where AI can explore GUIs on its own?
Right, so understanding the history helps us appreciate how far we've come. Early attempts at GUI automation were very different from what we see today. So instead of AI, it was all about hand-coded rules.
Yeah.
Right? Programmers had to explicitly define every possible interaction with the interface.
Yeah, I remember reading about those early systems. They were incredibly rigid and prone to breaking. Any little change in the interface and the whole system could just crash.
Exactly, yeah.
It doesn't sound very efficient.
Not at all. And that's why the introduction of machine learning was such a game changer. Instead of relying on these fixed rules, algorithms could learn patterns and relationships directly from data.
So it's like moving from a rule book to a learning manual.
Yeah, exactly. And the early machine learning approaches focused on recognizing and classifying GUI elements, like buttons, text fields, menus, things like that. It was a first step toward AI actually understanding, the visual structure of these interfaces.
And this led to those early GUI grounding models.
Yeah.
The ones that could connect natural language instructions to specific actions on the screen.
Precisely. And early on, they used fairly simple techniques like keyword matching and basic image analysis. But as the research progressed, we started seeing more sophisticated approaches like deep learning and computer vision, which enable the AI to handle, more complex instructions and variations in GUI design.
So we went from basic pattern matching to AI actually learning to understand and interact with GUIs on a much deeper level.
Exactly. And that brings us to the present day where we have these incredibly powerful multimodal large language models, or MLLMs, like the one used in GUI-B.
It sounds like these MLLMs are key to making AI systems like GUI-B possible. They can understand both the visual layout and the underlying functionality of a GUI. It's like they've given AI a whole new level of visual literacy.
Yeah, that's a great way to put it. And with that understanding, they can explore and learn in a way that was just unimaginable a few years ago. This paper really showcases how far we've come and hints at the incredible possibilities that lie ahead.
Okay, so we've got this brilliant system, a bit of historical context, and now I'm itching to know, how well does it actually work? Did GIB live up to its potential?
That's a great question. So to test this, the researchers built this brand new benchmark called Novel Screen Spot.
Okay.
You can think of it like a proving ground for how well AI can adapt to new GUIs.
So it's not just testing on familiar interfaces. They're really throwing some curveballs at this AI, right?
Exactly. They included 5 diverse web environments, so ranging from online shopping sites to forums, even a photo editor.
Wow.
And crucially, these environments were intentionally designed to be different from what existing GUI models had been trained on. It was a real test of adaptability.
That makes sense. So how did the models perform? Did this specialized training from GIB actually make a difference?
The results were very impressive. Models fine-tuned with data collected by GUI-Bee showed significant improvement in accuracy compared to models trained on, more general data. It showcases the power of targeted exploration-based learning for adapting to new environments.
It sounds like this could be a game changer for how we train AI to interact with the digital world. We're moving away from rigid systems and embracing adaptability.
Absolutely. And what's even more exciting is they tested the system in 2 ways. First, they used only visual information, essentially screenshots of the GUIs,
Oh, hey.
and then they added what's called an accessibility tree, which provides additional structural and textual data about the interface.
So it's like giving the AI two different ways of seeing the GUI, one focused purely on visuals and another with more detailed information about the elements and their relationships.
You got it. And interestingly, the models performed even better when they had access to both the visual information and the accessibility tree.
Makes sense. The more information the AI has, the better it can understand and interact with the interface. It highlights the importance of providing AI with, rich, multifaceted data.
Precisely. This idea of combining different modalities of data will undoubtedly continue to be a major focus in AI research moving forward.
This is all incredibly fascinating, but we've only just scratched the surface of this paper. After a quick break, we'll come back and really unpack what this all means and explore some exciting and perhaps even little wild possibilities. Stay tuned.
Yeah,
Welcome back to Talk Tensors.
right. And I'm really excited to dig into what this research means for the future of AI. It feels like we're on the verge of something big.
Yeah, I agree. GUI-B's adaptability, hints at a future where AI can seamlessly navigate the digital world, handle new interfaces and challenges with ease.
This makes me think about all the ways this technology could improve our lives. Imagine never having to figure out a complicated website or app again. AI could just handle those unfamiliar interfaces for us.
That's a great example, but it goes beyond just user convenience. Think about accessibility. GUI-B could pave the way for AI assistants that can help people with disabilities navigate the digital world, more easily. That would be incredibly impactful. It really highlights the potential for AI to make technology more inclusive.
Exactly. And it makes you wonder, where else could this type of adaptable AI be applied?
That's what I love about this show. It's time for our Novel Notions segment, where we speculate about the future. What if we took these principles from GIB and applied them to other domains?
Oh, I'm ready to get speculative. What are you thinking?
Well, GIB is all about exploring and understanding digital environments. What if we could apply that to the real world? Imagine an AI robot equipped with similar exploration capabilities.
That's a fascinating idea. Instead of exploring websites, this AI could be exploring a forest, a city, or even another planet.
Exactly. It could learn to navigate unfamiliar terrain, identify and classify objects, and maybe even interact with its environment in meaningful ways.
It could revolutionize fields like search and rescue, environmental monitoring, and space exploration. We could send these robots to places that are too dangerous or difficult for humans to reach.
Think about a robot exploring the depths of the ocean or navigating a disaster zone. It could gather critical information and relay it back to human operators.
It could even learn to adapt and improvise in unexpected situations, something that's really hard to program into traditional robots.
This is getting me really excited. It feels like we're talking about a whole new generation of AI systems that can truly learn and adapt to the world around them.
And remember, GUI-Bee uses that clever QICRL system to guide its exploration, prioritizing actions that lead to new discoveries. We could apply the same principle to a real-world exploration robot.
So instead of getting stuck in a repetitive loop, it would constantly be seeking out new information and pushing the boundaries of its understanding.
Precisely. It would be like having a curious, tireless explorer constantly pushing the frontiers of knowledge.
But let's take this even further. What if we applied this concept of adaptable AI to scientific research itself?
Ooh, I like where this is going. You're thinking of an AI scientist.
Exactly. Imagine an AI that can explore vast data sets of scientific literature, experimental results, and raw data from instruments. It could use a system like QICRL to guide its exploration, focusing on areas that are most likely to lead to new breakthroughs.
That's a brilliant idea. Instead of relying on human scientists to sift through mountains of data, this AI could automatically identify promising research directions and generate hypotheses.
It could even design and execute its own experiments, analyze the results, and refine its hypotheses based on what it learns.
It would be like having an army of tireless research assistants working around the clock to push the boundaries of scientific knowledge.
And because it's constantly learning and adapting, it wouldn't be limited to existing scientific paradigms. It could potentially discover entirely new fields of study that we haven't even thought of yet.
That's a powerful thought.
Yeah.
It's like giving AI the tools to become a true scientific pioneer, constantly pushing the limits of human understanding.
But of course, we need to be mindful of the potential challenges and ethical considerations that come with such a powerful technology.
Absolutely. Any AI system that's capable of independent research would need to be carefully designed and monitored to ensure that it operates within ethical boundaries.
We need to ensure that its goals are aligned with human values and that it doesn't inadvertently cause harm in its pursuit of knowledge.
Right. It's crucial that we approach this type of research responsibly and thoughtfully, but the potential benefits are so vast that I think it's worth exploring.
I completely agree. This is all still very speculative, but it's these kinds of what-if questions that drive innovation and push the boundaries of what's possible.
It's the spark of curiosity that fuels scientific progress. Who knows, maybe one day we'll have AI scientists working alongside human researchers, making groundbreaking discoveries that benefit all of humanity.
That's a future I'm excited to see unfold. And that's the beauty of AI research. It's constantly evolving and pushing us to think bigger and bolder.
Exactly. It's a field that's full of surprises and endless possibilities.
Well, on that note, I think we've covered a lot of ground in this deep dive.
We've gone from the technical intricacies of GUI-Bee to some pretty mind-blowing speculations about the future of AI exploration and research.
And I hope our listeners have enjoyed the ride.
I think it's safe to say that this is just the beginning of a much larger conversation about the role of AI in our world.
We're excited to see where this technology leads us and how it continues to shape the future. But before we wrap up, I have one last thought.
I'm all ears. What's on your mind?
We've talked about AI exploring physical environments and scientific data sets. But what about exploring the vast and complex world of human creativity?
That's an interesting direction. You're thinking about AI artists, musicians, writers.
Exactly. What if we could create an AI system that could explore different artistic styles, techniques, and mediums? It could analyze masterpieces from history, experiment with different creative approaches, and maybe even generate its own original works of art.
That's an interesting proposition. Yeah, it raises so many questions, about the nature of creativity and whether a machine can truly capture the essence of human expression.
It's a valid perspective. But I wonder if we're underestimating AI's ability to surprise us.
Yeah.
After all, creativity is often about pushing boundaries and challenging conventional thinking. Maybe AI can help us do that in ways we never thought possible.
It's certainly an exciting prospect. Imagine an AI composing a symphony that evokes emotions we've never felt before, or painting a masterpiece that, challenges our understanding of beauty and form.
Or writing a novel that explores themes and characters in a way that's, completely fresh and unexpected.
Oh,
It could revolutionize the art world as we know it.
Yeah, but as with any powerful technology, we need to proceed with caution.
Uh,
We don't want to create AI artists that simply mimic human styles or churn out derivative works. The real challenge is to foster AI creativity that's genuinely original and thought-provoking.
that's where the human element comes in, right?
Yeah.
We need to guide AI's creative exploration,
Uh-huh.
provide feedback, and ensure that it's aligned with, our values and aspirations.
It's a partnership that requires both technical expertise and a deep understanding of the creative process. But the potential rewards are immense. Imagine the breakthroughs we could achieve if we could harness the power of AI to amplify human creativity.
It's a future that's both exciting and a little bit daunting. But that's what makes this field so captivating. It's constantly pushing us to ask bigger questions. And imagine a world where the boundaries between human and artificial intelligence become increasingly blurred.
And who knows, maybe one day we'll look back on this episode and marvel at how far we've come. The seeds of those future breakthroughs might be planted in these very conversations.
That's a great point. Innovation often starts with a spark of curiosity and a willingness to explore the unknown, and that's what Talk Tensors is all about.
So to our listeners, we encourage you to keep exploring, keep questioning, and keep those tensors talking.
And if you're interested in learning more about the research that sparked this conversation, be sure to check out the full GUI-Bee paper, which we've linked in the episode description.
Until next time, keep those minds curious and the possibilities endless.